Hello and welcome to Web Math Academy, where today we're going to continue our study of complex numbers as it relates to something called RLC circuits. These are AC circuits that have components in them that vary with the voltage. The resistors, capacitors, and inductors are the three components we will look at, and they are given by their labels down below here, R, C, and L. And we talk about those in the terms of resistance. The resistance for resistors is given by R. The effective resistance for capacitors is given by X sub C. And the effective resistance for inductors is given by X sub L. All of these resistances are measured in ohms, which is given by the symbol here. Now, in AC circuits, the phase of the voltage matters. Here we have, if I is the circuit current, then V voltage, IR for resistors, and is in phase with the circuit current. This is shown by the graphs down here. Here's a sinusoidal wave of the current, and here is the voltage of the resistance, also in phase with the circuit current. Voltage equals I X sub C for capacitors and lags the circuit current by 90 degrees. And that is shown here. You can see that the peak of the wave happens 90 degrees further down the line than the current here. Finally, V for inductors is I X sub L, and this leads the circuit current by 90 degrees. That is, it comes before the circuit current. So we can see on the VL graph here that the voltage leads the current by 90 degrees. Here it reaches its maximum value at time equals 0, and here the current reaches its maximum value 90 degrees later. Now to plot this on a complex number frame, we use the real axis as the resistance from the resistors. We plot the resistance from the inductors on the positive imaginary axis, and we plot the resistance from the capacitors on the negative imaginary axis. So having said this, the total effective resistance is called the impedance, and it is given by the complex number Z, which equals R, the resistance, plus, and here's the complex part, X sub L minus X sub C, where J here replaces the traditional I we use, so as not to confuse with the circuit current I. The voltage then for the circuit is simply V equals IZ. Now converting to polar coordinates, that gives us Z, the positive value, absolute value, equals the square root of R squared plus X sub L minus X sub C squared. And then the theta, the phase, is the inverse tangent, X sub L minus X sub C over the resistance R. So if this theta angle is positive, we say that the voltage leads the current. And that would be if it was in this area here. If theta is negative, the voltage lags the current. In that case, we would have a graph somewhere in this range here. So let's try an example. Here we have a resistance of 6 ohms, an inductor effective resistance of 10 ohms, and a capacitor effective resistance of 18 ohms. Finally, let's use our current to be 5 amps. So we can substitute these values into our equations for the impedance and the phase, and we can do that using our TI-Nspire calculator. So first for the impedance, it'll be the square root, control, square root, it'll be 6 squared plus parenthesis 10 minus 18 right parenthesis squared equals 10 ohms, that's our impedance, and then the phase angle is the inverse tangent. For that, it's the trigonometric button, tangent -1, and then we're going to want to use a parenthesis here, and it'll be 10 minus 18 right parenthesis divided by 6 right parenthesis again, enter, and that gives us a wholly unusable answer, which we can convert easily enough by going to menu, number, convert to decimal, enter, and it comes up with negative 53.13 degrees, which is the answer we have listed for you over here. Now, since theta is negative, we know here that the voltage lags the current. Now, this is graphed on our calculator also, and we can see that because it's in this quadrant, we know that it's a negative angle, negative 52.13 degrees, and that the answer is 6 minus 8J, or a total impedance of 10. This is just an introduction into complex numbers with the use of RLC circuits. If you have any questions or want to learn more, please follow our website at webmathacademy.com. Thanks.